This is the screencast for section 3.6, example 4. We're going to find an interest rate this time. So our variable is going to be our interest rate. Stephen has $500 to invest. What annual interest rate, compounded quarterly or 4 times per year, is required to double his money in 10 years? Well, I have a lot of stuff that I can fill in. Let's see. A equals his initial investment was $500. We have 1 plus, now his interest rate we don't know, so that's going to be R over. It's compounded quarterly, so that's 4 times per year to the 4, and then now we actually know that it's 10 years. As a matter of fact, we also know that he wants to double his money, so he wants to earn $1,000. Well, 1,000. So I can solve this by hand. Divide both sides by 500. And then I get 2 equals 1 plus R over 4 to the 40. Now as you can see that it doesn't matter how much he invested at the beginning. If he, like this expression shows that he invested $1 at the beginning and he wants to produce $2. He's doubling whatever it was he started with. It doesn't actually matter how much he started with, because if the initial amount he started with were $700, his doubling amount would be $1,400. You divide by that coefficient right off the bat and you still get 2. So just the fact that he's doubling, you could start him off with an investment of $1 and aim for $2. That's okay. Next, I need to take the 40th root of both sides of this, which sounds absolutely ridiculous, but that is what I need to do. So now I'm going to have, let's see, the 40th root of 2 equals 1 plus R over 4. I'm going to subtract 1 from both sides. 40th root of 2, and then minus 1 equals R over 4. So then I'm going to multiply both sides entirely by 4. So now I can use my calculator to find out what 4 times the 40th root of 2 minus 1 actually is. So I get that R is about, let's see, it looks like 7.99%. I can also solve by using my graph, the graphs. If I put in y1 the equation that represents his investment, and then y2 1,000, the catch is getting a good window. My x-min I put at -0.1 and my x-max is just at 1. Remember, your x this time represents your interest rate, and your interest rate isn't going to be higher than 1 because 1 is 100%. So that's why I made my x-min -0.1 and my x-max basically 100%, and my x-min is -10%. My y-min is going to be -300. My y-max was 1,300 just because I was looking for a y value of 1,000, so I made it 1,300 so that I could see that. I look at the graph, second calc, intersect, and I get the same value that I did by hand, so I know that I'm right. The now try problem is number 25, finding the interest rate. So again, we're looking for that interest rate. What interest rate compounded daily, 365 times a year, okay, is required for a $22,000 investment to grow to $36,500? So I'm looking for an output of $36,500 with an initial investment of $22,000. And that went for, let's see, 1 plus, we don't know the rate, but that gets compounded 365 days a year for, let's see, that'll be 365 times 5. Yikes. All right, so I'm going to divide both sides by 22,000. So I get 73/44 with a little help from my calculator is 1 plus R over 365 to the 1,825th power. Again, a little help from my calculator. So I need to take the 1,825th root of both sides, then subtract 1, and multiply both sides in their entirety by 365. So I get that R equals, R is 0.1013, which results in a interest rate of 10.13%. And of course I could graph that in my calculator and find the intersection as well, just to double check my work.